Okay, so next problem in the lead code we are solving is unique pass. Okay, here we have given the m cross n board. Okay, and initially the problem statement here is like we have the robot in the start location which is 0 comma 0. Okay, we'll have to this is the finished one. Okay, like I mean this will be end board, right? So now we need to go from here to here, and we need to find out how many possible unique paths are there. Okay, so how we can approach this problem is like one way is we could have to build the path, we can go to, as we are going to combinations, right? We can simply use the backtracking method, correct? So we'll try to go down, and then if we don't there, like let's go right side and keep on going to the right, and similarly we'll have to try out all these combinations. Okay, so this is how it looks actually. Like I mean, what we can do is we can have a function called backtracking function called macmo. Okay, so this will be the recursion where, okay, so if you just try to visualize how the recursion might work, so it will be like we'll be going down, and once we go to the down there is nothing, so we'll come back here, come back to this state, and we'll be iterating again this way, right? Like I mean, we'll in each state we'll try to go to the down, and but there is nothing, so we'll go to the right side. Okay, so we'll be keep on going till the here. Okay, and finally, like I think once we like I mean once this is everything is done, right, we'll come back to this state and we'll go to this one. Okay, and again we'll come back the come down, right? So like I mean every time we'll be checking their combination, right? Once we down go there, so we'll come to this point again, and again we'll do the same thing, right? So this is how the recursion way would work. And as we know, like I mean here we are duplicating many things, right? And obviously it will lead to the time complexity, like it will have the high time complexity. So now what other approach we can use here, right? So okay, let's try to visualize this. Okay, now how we can use the dynamic programming and how we can store the previous values to get the next values, right? So that we'll see now. Mm, so for example, let's forget everything about this board. So let's just concentrate on this part. Okay, like let's say that we want to reach here. Okay, we want to reach here, and when you want to reach here, like from where you can reach, right? Like if you check that, like there is only one two ways, right? You can either reach here or either you can reach from here, right? Is there any other way? No, right? Like we can move only from down or right, correct? So this is the only two ways that is possible. So now if I already know that this took x number of possible paths, like I mean this, or like maybe this one, right? Like if I know this possible paths, like I mean it took to reach here, and this is the y number of ways that it took to reach here. If I know that, right, I can take a simply the sum of it, correct? So the finish whatever the possibility will be equal to the sum of this location and sum of this location, right? So now we can now generalize a formula, right? This holds good for any of the coordinates you see in the grid. So if I want to take the possibility of this, right, obviously it will be I can go to this location from either this in these two possible ways. So if I take a tau sum of it, I can get it here, right? So now let's say that now okay, now we got a formula, right? Like I mean whatever x minus, like let's say that if you take it as an x comma y, so it will be like sum of x minus 1 comma y, and like I mean this value plus x comma y minus 1, right? Like I mean if you take a sum of it, like you will get the possible, like I mean total sum here, correct? So now we can apply the same formula to any of the coordinates to get the value, output value. Okay, so let's say that to build this obviously we need a previous one, right? We need this and this, correct? And also like I mean let's say that to build this one we'll need this and this, correct? So ultimately, so in this case we can apply the same formula from the start so that we can reach here. Okay, so now let's see, let's say that we are already let's initialize it to 1. Okay, and actually this is the common thing that I am seeing in the dynamic programming, that whenever we initialize the DP board, like initially it will be 1, or like I mean it might change, but that's not sure. But yeah, let's initialize it to 1. Okay, for now, because or else, but just to visualize here, what I can say is let's forget about 1. Okay, so how many ways that you can reach here? Okay, this is number of only one ways I can reach here. And also like how many ways you can reach here? This is also one. Okay, this also you can do. Okay, so like I mean to simplify, like we can say you can keep it as 1 to generalize, like I mean to true to our formula, right? We can keep it as 1. Okay, so now next thing is like I mean in all these rows, right? Like in the zeroth row, it will be always, it will be 1, because we can go only left, correct? Like I mean we cannot go from top, so we don't need to consider. So we just need to consider from the left one, so there will be only one path. Okay, so now, and also for like I mean for this also it holds the same. We can go only from top to bottom, and there is not there we cannot come from left, so we don't need to worry about that. So we can just initialize everything to 1. Okay, so so we'll say that initially we can during initialization time itself we can initialize the full board with the value 1, so that we don't need to explicitly handle this condition. Okay, so okay, let's check the code actually. Like I mean let's say that if you are in the one condition is if you are in that corner, right? Like I mean this or this, we can just say it is 1. Or else if you are inside it, you'll have to take a do a calculation that you will take a sum of this and this. That's it. Yeah, let's check the code. So this is the code for recursion. Okay, backtracking method. And this is the code for like I mean using the DP. Okay, we will initialize the board with m cross n with the value 1. Okay, and however will be overwriting the values for this one. Okay, we'll be overwriting the value for this one, but we'll keep the same value for the corners. Okay, so so that's why we initialized it to 1. And here we'll be iterate through the each board. Whenever we are in the corner, we have already set it to 1, so we don't need to set. And or else we'll take a calculation, we'll take a sum of the top element and the left element, and finally we'll be returning the last value. Like I mean that will have the total unique paths. That's it. Thanks.